Yours good. Today got a quick question based off of thermochemistry. Been a minute since we did this, and I might as well just bring us back over to it. Bro, my voice is gone, bro. I was emceeing an event today. Oh my god, bro, it's actually cooked. Anyways, so what does it mean for a reaction to be spontaneous? Well, in order for a reaction to be spontaneous, the change in Gibbs energy must be negative. It should be less than zero. That is the requirement for it to be spontaneous. So we need to find out how we will like form a relationship between change in G and what we have. So based off of my formula sheet, the reaction that we need to use, or the equation I meant, is change in G is equal to change in H minus T change in S. And also, I forgot to mention, this will be we'll just be using like standard conditions, kind of. So in order for change in G to be negative, wait, I don't even know what I'm trying to say. So we need the temperature, that's the question mark, yeah? So we don't know this. We know that this is going to be less than 0, and we can find out change in H and change in S. So that's what we're going to want to do first. So we'll just find out change in H. Change in H is going to be equal to end products. Okay, so yeah, well, let me just make sure this is my data sheet that I have here. Otherwise, I'm probably doing something wrong. LMNOP, silicon. Okay, yeah. Okay, so what we're gonna do is number of moles is 1, so we're not gonna really bother about that. But change in H is negative 1614 kilojoules per mole. That's the products. Minus, I'm not gonna write that. 1 times silicon. Silicon is 0 because that's like the natural elemental form of it. SI solid, yeah, 0 kilojoules. Oh, we don't even need moles here because we already multiplied by moles. Whoops. 0 kilojoules, and then 2F2 gas, 2 fluor, like 2F, like, bro, so it's just fluorine gas, bro. 2 moles of fluorine gas. That will also, I'm assuming that's going to be 0 as well, just to make sure. I'll just check this appendix. Yeah, 0 plus 0 kilojoules. So here we have our standard enthalpy of change. This is going to be negative 1614 kilojoules. So that's step 1. Step 2 is to find change in S, which we'll do right now. So SiF4, what is the change in S going to be? Silicon fluoride. Silicon tetrafluoride, I think, right? Which one is S? 282.4 joules per Kelvin. So that's our products. Now, according to our equation, we need to subtract the reactants. So what is silicon? 18 joules per Kelvin plus fluorine 2 times 158. Oh wait, no, 202.7 joules per Kelvin. Okay, let me just add that up really quick, and we should get an answer. What you got? 282.4 minus 18. Wait, did I write 202? Yeah, I think 202.7. Okay, we should get negative 141 joules per coulomb. So that's going to be our change in S. Okay, so we basically have most of the question done now. We just have to substitute these into our equation. So we know that delta G is going to be less than 0. So if delta G is equal to change in H minus T delta, if okay wait, my bad. If delta G is equal to delta H minus T delta S, that means delta H minus T delta S must be less than 0, right? So change in H minus, I'll just write this. Change in H minus T, change in S will be less than 0. So now we'll just bring that down here. Why did I erase that? I don't really know. I'll just show my steps because there's something important here. When we eliminate the negative from both sides, we need to make sure to flip the sign. So hopefully you know that. Otherwise that would be kind of cooked, but it's just basic math. Now we're going to substitute these values in. Change delta H is equal to negative 1614000. Remember that we're going to be using this in joules because our bottom unit is in joules, so we want to keep them constant. Negative 141 joules per coulomb. This should be equal to 1614123 divided by 1415. Oh no, 141. Delete. Okay. I got a value of 11446.8 Kelvin. How many sig digs would there be in this question? Well, 1, 2, 3, 4. 1, 2. I don't know. Let's just leave it to the nearest number. Honestly, I'm not trying to deal with that. 11447 Kelvin. So temperature. Wait. Hold on a second. Something's off here. Did I flip that sign wrong? Dude, do I not know how to do math? Okay, the answer should be T is less than this. But I don't know why I got greater than. Because delta G must be less than 0. So if you flip it. Okay, wait, this is looking confusing. Yo, there's no way I don't know how to do this. Do we just not flip it then? Yo, I swear we have to flip it, bro. Maybe not. Yo, what? Wait. Delta G is less than 0. Delta G is less than 0, so then. Yo, I feel like I messed up the sign. Yo, for a thing to be spontaneous, it has to be less than 0, yeah? Yeah, bro, I don't know. This is marked as correct on my thing. Maybe I was wrong then. I guess we don't flip the sign, bro. What the heck? That's weird. Okay, well, anyways, temperature must be less than 447 Kelvin for it to be spontaneous. Okay, well, that's all. Honestly, I'm a bit confused about how this is, why we don't flip that sign, bro. I swear, bro, I literally tutor math, bro. This is literally like one of the most basic things, bro. And I'm tweaking over it, bro. I don't know. I'll see you tomorrow, bro. Goodbye.